Welcome to EELE 371, Introduction to Microprocessor Hardware and Software. My name is Brock LaMeres and I will be your instructor for this fully online course being offered by Montana State University during the summer of 2024. This course is also called Embedded Systems Design for short. The purpose of this video is to give you an orientation to the topics that we're going to cover in this course and then look at the logistics of how you're going to engage in the learning activities, how you turn in deliverables, and get started on the course right away. All right, so let's get started. Okay, so let's take a look at kind of the overview of what this class is. So you guys have all heard of computers, right? Everybody's heard that word. And when you think of computers, you tend to think of general purpose computers. So you've all worked on laptops or workstations, with full monitors and keyboards. And those are indeed computers. It's hardware that's designed to accomplish a certain set of steps or instructions, and then you provide which of those instructions and in which order it should execute by providing a list of codes, which is called software. Okay, and we think of a computer as just sitting on our desktop, but we also have phones in our pockets that are also computers. And so those computers, you can tell right away, they're a little bit more limited, right? The keyboards are smaller, they don't have as much capability. They still have a lot of capability, but they don't have as much capability and aren't as general purpose as the workstations. But then there's a whole nother class of computers that are known as embedded computers, also called edge computers. And these are the computers that exist in all of modern electronics that essentially run society. So these are in, office equipment like your printers, they're in your TVs, they're in the microphone I'm speaking into, they're in the mouse that I'm using, they're in absolutely everything. And these computers are dedicated to specific tasks. So if you think about a mouse, for example, it is going to read the XY location based off the table based upon your movement and send that up to the computer. It's very specific. It doesn't run an operating system. It doesn't allow you to connect a keyboard. It just does its own task and that's it. But it is still a computer. It is still hardware that is designed to perform a certain set of instructions, and you provide which instructions to execute and in which order via software. So it turns out there are far more embedded computers in the world than there are general purpose. In fact, there's literally 25 to 30 billion embedded computers sold each year that keep society running. And so when we look at how to learn how computers work, okay, we need to know a couple different things. Number one, we need to know the hardware. All right, so we need to know things like memory and the central processing unit and how that all works. But we also need to be able to write software. So we need to be able to program it. And it would be really cool if we could do all this using a computer where we could see what's going on. So we in this class focus on an embedded computer as a means to learn how computers operate from both a hardware perspective and a software perspective. This extends to all computers, including general purpose computers. So this class will give you an overview of how the computer actually operates down at a low level. A side benefit of this is that when you program an embedded computer, you learn about kind of the nuances of how it's a little bit different than a general purpose computer, how it's got built-in peripherals that are designed to interact with like the real world. So it's got, analog to digital converters, it's got serial peripherals, and you start developing a skill set that is actually highly sought after. So you can come out of this class and be like, well, I know how to write embedded software. And it's like, holy cow, I'll hire you because we need somebody to program this computer in a robot that we're building. Okay. So it's kind of got a dual purpose outcomes on this. So let's look at kind of the modules we're going to cover. There are a lot of modules in this and they don't all take a long time, but we start off the class by just talking about what an embedded system is. I basically just told you. Module 2 is a review of digital logic basics. So you should know all the stuff in Module 2. It's a long module. That's by design. It's a reference for you. You should know things like AND gates and OR gates and understand what a finite state machine is and what registers are. Module 2 is not supposed to be new material. If you've never heard of any of that, you might want to contact me because this might be a challenging course if you don't have that background. And then we move into the content specific to this class. We talk about computer systems all the terminology that's used, all of the, what hardware is, what software is. We break it down to get to the point where it's like, okay, we know what's going on under the hood. Then we introduce the computer we will be using, which is called the MSP 430. This is a little computer from Texas Instruments. Sometimes you'll hear it called an edge computer. Sometimes you'll hear it called an embedded computer. Sometimes you'll hear it called a microcontroller. All of those terms are accurate and interchangeable. And this little fella is awesome because it is in the prime of its life. So it's widely used. You'd be shocked at how many systems are actually using this today. So it's a relevant microcontroller. It's also really, really inexpensive and it's really low power. And it comes on this red board, which we call the Launchpad board. And this allows it to be able to be operated and programmed using just a USB cable. So this means that if you have a computer or you have a laptop and a USB cable, you can plug it in, power this thing up. You can write software for this, download it, execute it, and look at what's happening. And that's how we're going to do this entire class. Is you're basically going to program this little microcontroller, this little computer over and over and over, and you can do it from anywhere on the planet. Okay. Module 5, we get into how you actually program it in what is called assembly, which is you program the computer at the instruction level. You don't write it at a high level like C. You actually say, hey, if I want to move information from memory to a register, I'm going to say move this address to this register. So assembly is an instruction by instruction programming approach, and we learn it because it really helps you understand how the computer is executed. Then we do 3 modules that cover all the basic classes of instructions in a computer. There's data movement, which moves information around memory to registers, registers to memory, registers to register. Then we look at data manipulation instructions. Those instructions manipulate data, like they add data together, they AND data together, they shift data. And then finally you do program flow, which is where you start making decisions and repetitions. So this is where you implement things like if-else statements and while loops and for loops. Okay, then we finally get to the point where we can access the outside world. So we start looking at digital input output. So this chip actually has pins on it that you can move up and down. So we can actually use this chip to drive LEDs and read from switches, and we can send information up the USB cable, and we can control motors with it. And so we learn about that. Then module 10 is where we start getting into a little bit more detail of the operation of a computer by looking at the stack and subroutines. And then 11 is where we look at interrupts, which is a kind of a hardware approach to handling asynchronous peripherals. Then we look at a specific peripheral, which is called a timer, which can basically keep track of time independent from the CPU. And those are useful. Then we take a step back and we say, you know what? Programming in assembly, taking a long time. Let's switch over to the programming language C. Now, this is where you need to have programmed in C before. If you haven't, you probably need to talk to me, because while we're not going to go really heavy into using C, we're not even going to access files. We're not using pointers, but you don't want to be learning microcontrollers at the first time that you're also learning how to program a computer at a high level. So you should have had some higher level programming experience. Hopefully in C. If you're at MSU, you should have taken CSCI 109 or equivalent. And if you're not at MSU, you should have had some programming course. If you've taken like Python, that's probably okay. But you should let me know, because it can be overwhelming, and you want to know right away, because you don't want to wait till the end of the course or midway in the course before you say, oh, I forgot to tell you, I don't know, I've never had the prereq of programming. Okay, we wrap this whole thing up with serial communications. There's actually 3 serial communications that you'll learn in this class. One's a UART, one's a SPI, and one is I2C. And these tend to be the most popular ways to communicate with a microcontroller to other little devices. And then we wrap the whole thing up with analog to digital converter. Okay. All right, so that's the topic. Let's look at how you actually engage in the activities. So, number 1. You are going to use Brightspace, which is the learning management system for this course. Learning management system means it's a website, okay? And the address is ecat, for Bobcats, .montana.edu. You log in with your NetID and password and you're in, okay? When you come in here, you're going to go to probably your normal landing area for Brightspace and it'll show all your courses. So over here on the right, you'll see my courses. Go over to summer 2024, click on microprocessor hardware software. The way that I laid out Brightspace for this class is I always have an announcement that comes active at the beginning of the week and goes away at the end of the week. And that way you're always oriented. So when you come into the class, you're like, oh no, am I in the right spot? And it's like, yeah, here's a little reminder, you're in the right spot. And this is what you should be working at a high level. So if I look at this announcement, it tells me a few things. It's like, hey, welcome. You need to have a portable lab kit like right now. And there's going to be deliverables on Wednesday of the first week at noon. And you look at this and it's like, holy smokes, we're really going. And it's like, yep, this summer class is 12 weeks and it flies. So we're going to have a ton of different homework assignments that are not all that bad. It's just a lot of different programming assignments. Okay. All right. The other thing about Brightspace that I do is I put everything in content. So if I go to content, I have a page for each module. So you've got the course information and syllabus, module 1, all the way down to module 15, and then your final project. And if you go into any of these modules, you'll see that I walk you through sequentially all the activities you should be doing. Okay, so every section in the book we're going to cover. Section 7.1, I have these calls to action in bold of what you're specifically going to do. Read, watch, do. This is an online class. You have a textbook. And I wrote the textbook. I actually designed the class first, wrote the textbook second, and then recorded the videos third. So the material is the same between the book and the videos. So if you enjoy reading more than watching videos, you should be okay if you just read the textbook. If you'd rather watch videos instead of read, you should be okay. But you should make sure to have the textbook so that you have that resource available to you. So when I come in here and I go read, watch, do, the watch are all the YouTube videos that I created for you. And then you have a do, which is going to be a multiple choice quiz. Every single homework in here is a multiple choice quiz. And then you have a lab after a few sections that is a programming assignment. Okay. So when you look at the Brightspace, you'll notice that up here at the top, you've got all the tools. Quizzes are one of them. If you went into quizzes, you could probably find all the quizzes. I mean, you could find all the quizzes, but you don't have to because I link them all in the content pages. So when I come down here, this points to a quiz that exists in the quiz tool. So I do it that way so you don't have to hunt around for everything. It's all in content, and that's all you need to remember. Okay, so that's what the quiz. I come back to my content page. The links to the videos are external YouTube videos. And then when you get down here to the labs, you look at a lab description. This is going to be a programming exercise. So you're going to have a set of tasks that you are going to do, and then you're going to record a demo video that shows your computer doing what it's supposed to do and talking through that, showing that it works. Okay. And I walk you through everything that I need for the lab, and I talk about the deliverables of what you're going to do. But your deliverable will be a video of it demoing and also your source code. Okay. And we give you an example in module 5 of once you get to the point where you're going to actually do a video upload. Our TA Drew created this example of what he would like to see, and he recommended using this system called OBS, or Open Broadcast System. And there's a little link to that you can play around with. But you can also you can use any software that you want, but you're going to need to be able to see like your MSP430. It'd be cool to see you if you want, and also your screen, because a lot of times we're having you show us stuff in the software. Okay, so that is kind of where everything is. Now let's look at the syllabus. And I have an information and syllabus page. This information page is a lot of the same stuff as the syllabus, except that I link to things. So as an example, Brock, that's me. You can call me Brock. Here's my email. Here's my WebEx room. Here's my website. Drew's our TA. Here's his WebEx room. Here's his email. So you can click on these links. We are working, like we're here. And if you need help, just email us. And if we can't answer it with email, or you want to jump on a call, we're just going to use WebEx. Drew's ready to go all the time. So he's the guy you want to contact if you want help. And if I need to get involved, I'll get involved. But Drew's awesome, and he'll be there for you. Office hours, we don't really have office hours because we're always available. So just email when it is and you're off and running. When you look at the required material, you need a computer with internet, and I don't know why, but this is one of the few pieces of software that does run on a Mac. So if you have a Mac, you're still slugging along with that thing. Now you have some false hope that you made the right decision where you get something that runs on a Mac. And after this class, nothing else will work. So you should just switch over to Windows now. The textbook is written by me, embedded systems design, using the MSP430 FR2355 Launchpad. This book is specifically written for this microcontroller for this class, second edition. If you want it, get it through Amazon. It's always cheaper than the bookstore, so we don't even stock it in the bookstore. You're going to check out a portable lab kit. Okay, this will become available in the ECE office on May 8th. Go see Deb. She's going to have them for you. She'll give you the MSP430 in addition to a couple other things, a little motor and a little timer that we can talk to over serial peripheral, and a couple other things. Okay, she'll also give you a Analog Discovery 2, which is a portable power supply and oscilloscope that you can use to do measurements. And then finally, you need a camera capable of taking short videos. Usually a smartphone, but if you use OBS, which is basically a screen recorder, and then it puts your laptop camera over the top, that's fine too. So you can use the video, your recorder or camera from your laptop. Okay. All right. As a final thing, let's look at the syllabus and talk about the most important thing, which is the deadlines. So when you come into here, this is a standard syllabus. Here's what the course is. Here's the learning outcomes. Learning outcomes are funny because usually if you talk about them in the beginning, you don't even know what these words are. So at the end of the class, if you come back and look at these, you should say, oh yeah, I know what that is. All this stuff is repetitive. We start the course officially on May 13th. It runs to a Friday, August 2nd. And this is required material already taken care of. Office hours, grading. Grading, basically you have 30% homework, multiple choice quizzes, 60% labs. That's where all the learning is, so that's where most of the points are. And then you got 10% your final project. So your final project will give you a chance to define something cool where you use multiple peripherals. Grading, I just grade straight, no pluses, no minuses. Academic policies. In terms of cheating, cheating is where you just turn in somebody else's work. Collaborating is where you work together to solve the problem. All engineering problems today are solved in groups and in teams. So you have to collaborate. So you are welcome to collaborate if you're in a position to do so. I know this is an online class. You might be spread out all over the country. But if you are in Bozeman and you get a study group together or something, that's fine. Talk about it, help your friends, get friends to help you, look at each other's code as reference. But where it becomes cheating is where you're like, I don't have it. I don't have the assignment because I slept in. Can I just upload yours? Or can I take a video of your microcontroller working? That's when it becomes cheating, is when you take credit for somebody else's work. But for sure, collaborate if you have the means. Course components, like we said, you can read, you can watch videos. They're one and the same. You do homework, multiple choice quizzes, lab assignments, and then the final project. And now the big table. This is what you really want to look at every time you engage in the course. This is the main schedule and deadline due dates. Okay. Every single assignment is due on a Wednesday at noon. Okay. So the first week we start, I have 2 assignments that are due on the first Wednesday. And that is to make sure that you start the course. We don't want this thing where you wait a couple weeks and then they're like, well, it's kind of not really paying attention. And all of a sudden you missed a bunch of assignments and then you've basically flunked out of the course before you even started. So I want you engaged immediately. So the first week you have assignments due on Wednesday at noon. After that, you get into a flow where the weekly material is due the following Wednesday at noon. Okay, so the rest of week 1's material is due the following Wednesday at noon. And then the next week, which would be week 2, its activities are due the following Wednesday at noon, and so on and so on. When you look at this, you can come over to the right and see the homework points and the lab points and the deadline. Notice the homework points are not worth as much as the lab points. That's because the homework, they're short multiple choice quizzes just to make sure that you actually watched the video or did the reading. Module 2, as an example, this is all review, so it's really not that relevant. But when you get to 3.1, 3.2, 3.3, I mean, they're short quizzes, knock them out. The key with the homework quizzes though is that they're due on the following Wednesday. You can open them, you can work on them, you can save them, you can leave, come back the next day, but you can't work on them after the deadline. The deadline comes, they're gone. So you have to submit it before the deadline. So please remember to do that. The reason when they're due on Wednesday, all the material should be able to be handled during the week. This is, 10 to 15 hours a week is what this class will take. It's a 4-credit class with a lab. But if you needed the weekend, like let's say you work and you're going to try to do this course on the weekend, that's acceptable. So we give you the weekend. And then it's like, well, do you want the deadline Monday at 8 a.m.? And it's like, well, if you worked on the weekend and you didn't have a chance, like me and the TA were traveling and weren't around on the weekend, you don't have a chance to get help. So then you could be like, okay, I need some help on Monday. So then maybe Tuesday, there's no good time for a deadline. So I do know that I want the deadline between 8 and 5 during work hours, because outside of work hours, there's so many things that go wrong. It's insane. So what I do is I say, let's just put it right in the middle of the week. So all the material, let's say for week 2 is during week 3, Wednesday at noon. Now, let me give you a warning. The material takes time. If you log in Wednesday morning and try to do all the activities for the prior week, you're not gonna have time to do it, okay? Because this is 10 to 15 hours of work. You can't cram that into 4 hours. So don't do it. Don't do it because you will fall behind. And as soon as you start asking me for deadlines, it's over. The class goes too fast during the summer to extend deadlines, because once you fall behind, you can never catch up. Because look at how many deadlines there are. It becomes this impossible wave that you've just fallen behind. So no deadlines will be extended. Don't work on this the Wednesday they're due. Work on them the week that they are assigned. Okay. Now, as you look through this, it's a little overwhelming. There's so many of these sections, but they're small. Even the labs are smaller than what you would think. So for example, during week 3, you have 3 labs. In a normal class, that's impossible. It's way too much work. But in this class, the labs are smaller. Okay. So you can do these. They're designed, you could do them in 20 minutes. Okay. It's just, we want you to have a lot of different touches with the computer, a lot of different time on it, or a lot of different repetitions on it. Okay. Once we get down to the end, the final week will be a final project with 100 points. It's pretty straightforward. It's just basically taking concepts we've already learned and combining them to have 2 or 3 different things running at once. And there you go. All right. So that is it. At this point, you should have your lab kit, or if you don't, get your lab kit. If you're out of town, contact me immediately and we'll mail it to you. And otherwise, you're ready to log into the course and get started on this. And I look forward to working with you this summer, and good luck.